This is insane. Teleportation is here, but it's not what we expected. Have you ever imagined being a child or even growing up to be able to teleport? How cool would that be, right? To be at a place and teleport to another seems pretty fun. Well, science has been a part of our lives trying to figure out things quite well, and who knows if scientists can make something to make our childhood dreams of having such superpowers come true. Hey folks, welcome back to Techverse, where today we are going to talk about what teleportation's all about and what scientists exactly did. So let's get into this video. But real quick, before we begin, make sure you subscribe to our channel and click the bell icon so you don't miss any of our amazing videos. And let's begin. When you're trapped in traffic for who knows how long, you think, I wish I could teleport to my destination. This time is no exception, and while you wait for that green light, you fantasize about a button-filled machine that takes you from home to work. Wow! Like Star Trek? How long will scientists, physicists, and engineers need to develop this? And how hard is it to build a teleportation booth? When traveling by car, you consider the optimal route. There are short, busy ones and lengthy, winding ones with less traffic. While the choice is still unclear, you think about Star Trek's teleporter. It's the most famous sci-fi one. In each episode, a squad of men enter the teleportation booth and were dematerialized from the spaceship's cabin and rematerialized on the planet's surface, a method that saved money by avoiding Enterprise landings and takeoffs in every episode. Synthesis and conformation of teleporter imagery. A machine reads and saves a person's information, then turns it into energy and back into the person's shape. If teleportation functioned in this manner, it wouldn't be as rapid as TV shows make it seem. Teleporting to work from home would take a few microseconds, while intergalactic travel would take longer. An energy beam must move at the speed of light between 2 points. Do we wish to teleport to Proxima Centauri? As we've described it, teleportation takes over 4 years. In Star Trek, faster-than-light travel and some communication are established technologies, but we have no sign we will ever breach the light-speed barrier. You're not interested in new worlds. You don't want to travel where no man is gone. You just want to avoid traffic. Still intrigued? You may live on the other side of the world and yet be on time. Californians can work in London. Before placing it in every organization or office, it must be tested. It would be awkward to have half your body there and the rest at home. You may recall a science fiction author imagining a talking head arriving without its body. The Man Without a Body, 1877. You quickly dismiss this as imagination. What if, while the system reads the traveler's information, something foreign is also scanned? Fly, La Mosca, directed by David Cronenberg in 1986, is a remake of 1958's L'Esperimento del Dr. K. La Mosca, which was The Fly from 1957. It was about a guy who teleported and emerged with fly DNA. The real challenge of Star Trek teleportation is coding the person's appearance to the last subatomic particle of the individual. What's next to convey the date and rebuild the traveler? Do tell us in the comments section below. One can still assume that scientists would discover new calculators or ways to make calculations, and they will still be able to store and analyze all the information needed for human teleportation. Maybe they can utilize solar energy more efficiently, multiplying humanity's energy supply. Heisenberg bypassing is unlikely. In 100 years, who knows what scientific and technological developments await? Lost in these thoughts, you switch on the radio to find company. Radio reports a successful teleportation experiment. As you learn the experiment's details, your initial excitement wanes. Quantum teleportation can immediately transfer one or more particles to any distance. Human teleportation doesn't transfer matter or energy, unlike quantum. Information about a particle is conveyed. Quantum teleportation is like a map you don't see until the end of the transport. Research groups throughout the world are developing quantum teleportation technologies. Photons, electrons, and atoms have been transported. They've utilized satellites to transfer quantum states 1,200 kilometers. Physicists are already thinking of new security protocols, new computers, and new kinds of communication. All of this is possible with our current knowledge. Quantum cryptography uses quantum physics. The idea of exchanging unreadable communications is as old as humanity. Quantum keys, constructed of particles according to quantum principles, are stronger. In cryptography, the superposition concept is used. Until a particle is observed, It is in a superposition of possible states. Once measured, the state has a unique, irreversible value. Since measuring a particle's attributes changes it, an unauthorized observer trying to read a transmission would be discovered by both sender and recipient. Quantum cryptography would be needed if quantum computers were employed, as classical keys would be too simple to divulge given their speed. Transforming the conventional computer's bit, which can only be 0 or 1, into a quantum system's qubit, which can store a superposition of the two states, increases processing capacity by orders of magnitude, much faster than doubling, tripling, or unfolding. In 2019, Google's 53-qubit quantum computer prototype Sycamore completed in 200 seconds, a calculation that would have taken the most powerful classic supercomputer 10,000 years to complete. It's incredible. The construction and management are also complex. The qubits must work without touching other particles, or they lose their superposition advantage over the traditional bit. With a quantum computer comes the quantum internet. To establish a quantum internet, not only must machines store and process information using qubits and quantum superposition, but the connection system between the machines must be rethought to transport these qubits. The new data transport will rely on quantum correlation and the ability to teleport particles from one machine to another. Quantum correlation, also called entanglement, is achieved by causing two particles to act as if they were one thing. Once you measure particle sizes, such as electron spin or photon polarization, the second particle will have the same measure. Simply measuring a second entangled particle can anticipate the result instantly. It doesn't matter if the two measurements are done in the same table or Proxima Centauri. This thought troubled Einstein and other 20th century physicists because it changes how we view nature and how it speaks to us. Quantum correlation allows instantaneous information flow across large distances. Do we have faster than light communication? No. You can almost imagine the radio physicist laughing under his mustache while describing the conundrum. Light speed remains unbeatable even when we try to converse with entangled particles. Even if we test two particles in quantum correlation, we get corresponding results, but the Proxima Centauri lab should still know what kind of measurement was done on Earth, and this communication would travel at the speed of light. 44 km fiber optic. The quantum internet poses technical challenges. Fiber optics can transmit quantum channels for tens of kilometers in present tests. Experiments use photons as entangled particles, and fiber optics is a common infrastructure. The record for quantum teleportation using optical fiber is 44 kilometers, set by Fermilab and Caltech in 2020. Quantum information teleported at Fermilab, Caltech is a step towards quantum. This vehicle ride was exciting, right? You were late for work due to traffic. In the meantime, you fantasized about the ethics of human teleportation and how quantum physics is different from physical reality. As you leave your car for work, you see that half of your coworkers are at headquarters. The others won't leave. In the previous 2 years, we've gotten to work without science fiction or college. We've all experienced mind-only surrogate teleportation. We are connected to the same virtual room through a digital device and the internet. We held meetings, interviews, and classes from home. One click suffices. Good connection and a camera. Remote employment decreased travel time, improved time management at home. How many loads of laundry did you do between meetings? And gave us more family time. Remote work has drawbacks. Lack of tranquility or space to work or study effectively and efficiently was the easiest problem to predict. Another insidious problem is screen wariness. Evolution's evolved us into a social species that interpret others' words and nonverbal cues. Without enjoying the journey, you question the value of travel. And that's all for today's video. We sincerely hope you enjoyed it. If so, please give it a like and share it with your friends and family. Don't forget to subscribe to our YouTube channel to see more of our incredible videos. And we look forward to seeing you in the next one. Have a great day.